Hello and welcome to Scientifically Speaking. Today I'm going to be showing how to make, or not even make, I'm going to show how you can use a magnet as a defense shield against metal objects, which, you know, magnets attract. Do they repel? In a way, yes they do. So here's a magnet. You can see there I've got north facing away, north towards us, east and west. What I'm about to do now is draw the shape of the field and how the field meshes and interacts at the inertial line. Field comes out, spirals into the field from the bottom, because magnetic fields do not reciprocate from one side to another. Direction of travel will be pushing and pulling, or depending on which field you're looking at, because there's two fields on top of a magnet, north and south, one covers another. So it's either pushing or pulling, or pushing or pulling. I'm just putting both of these in so that you know it pushes and pulls in two different directions. One is dominant. The pull is dominant. The push is underneath. But on the other side, it's the other way around, as I've drawn there. Now there would be another two fields on top of this, the inverse reflection of what you see now, which is why I write push, pull, because the field can do either. It can either push out or pull in, because there's nothing attractive or repulsive about a magnet. It rotates matter in or it rotates matter out, and it's doing both. So I'm going to draw it now, because otherwise I'd have to turn this upside down. I'm going to draw the right hand field, but it's going to be pulling in, so that I can explain how to use the inertial line as a deflection shield. So I'm going to draw exactly the same, which is why you can either push or pull, but I'm going to change the rotation of the arrows, because that's the difference in rotation of the field. One's pushing matter out, one's pulling matter in, but they're both arranged so they push and pull. So that would be the travel of an object path. So it would come at the inertial line, and then it's going to travel up and over. So it's been deflected, but it's actually been attracted. But you can use it as a deflection. That there says the object would be deflected to the north or the south, depending on which side of the inertial line it approached, which is why Russia gets hit by a lot of large meteorites. So due to the pull of the magnet, which is in fact the rotation of the magnetic field, which is, I've shown that on video with spheres of matter being rotated in, due to the rotational pull of the magnetic field, the object is deflected, or can be steered away from the inertial line. And now I'm going to show this using some 4-inch metal screws. And that, by the way, is the inertial line. This is what splits north and south, which again shows that there is no reciprocation of a field on a magnet. And I think it's the 8th today, not the 10th. I don't care what the date is. Okay, so we have the magnet here, north face, south face, inertial line. All the coverings come off this magnet, but it doesn't matter. 1 inch by 1 inch neodymium magnet. And today I'm going to show you how a simple magnetic field with a bit more improvement and computer controls can deflect any metal object. So it's not like you have to do anything special. I'm going to show this magnet deflect this screw.
Just an everyday metal screw. Now, we all know that magnets like to attract metal. So how is it possible that this magnet will also deflect this same thing here that is trying to grab hold of it? Okay, so we can all see it's pretty obvious. Other side. Yeah. Now there's a property of magnets, and I just showed it on the paperwork beforehand. I want you to watch this. So that's the inertial line. Let's see what happens to the screw. Do you see that? I can almost lay that flat. See? See how it had to grab it, but it took its time. My point is, it is being deflected away from the inertial line. And now I'm going to prove it, because now I've got it in my fingers, and I'm just going to push down. It's going to knock the magnet over, because I can't put it into the middle. Too close. So now I'm going to take this with my fingers, push it down. Do you see how it spins? Here we go. And there we go. Now obviously I'm having to jerk it away so it doesn't jump up to meet the magnet, but I'm pushing over the magnet with a piece of metal. Not another magnet, nothing like that. In fact, where did I put those? A few more here in case anybody decided to say that perhaps it was magnetic. So I've got a few more here. Just got to be careful it doesn't leap up, but it's going to push it over. That one. There we go. You may say it's trying to spin to reach the magnet, and you would be correct, but my whole point is it can't. I can't push this down. I'm going to try and hold this now. It keeps pushing it. It pushes it sideways because what it's trying to do is pull it over to here. But here, I can't. If I let's get me one on the string. There is absolutely no way. I'm going to stop it leaping now. But there's absolutely. It wants to push it sideways and then go to the top, the north or the south. And this is my point. If you could have a defense system that as this bullet comes in, or wherever's coming in, you generate an inertial line field. Then, when the projectile is pushed this way, you turn it off. And then where's the projectile going to go? It's going to go that way and miss you. So, if you want to build a defense shield, you make it so that the inertial line is facing the object, because you cannot push this down to the inertial line. So if you can make a magnet north-south, north-south, an inertial line here, you cannot push it into the inertial line. So if you can make the field here, have it computer controlled so that when an object is detected within the field, which you could use a laser interferometer for that, it would then turn on this with the inertial line facing exactly where you are, where the bullet is, and then as it changes direction when it comes in and goes like that, you turn off the field and it goes that way. So that's how to build a very complicated defense shield, but the principle on the magnet is it will not let me put it into the inertial line. And you can only do, okay, just go out and get yourself a magnet. This is pushing me across. So if you can make the inertial line, if I seriously stab it, if you can make this really powerful and make this inertial line piece very wide, it'll keep trying to take it to the north and south. And I believe that's why a lot of asteroids coming in don't really hit Europe and anything along the equator, because they come in, they get deflected, and then they get pulled over, and normally they end up in Russia. So I believe that's a planetary defense system we have on our inertial line, our equator, where anything coming in to hit actually gets deflected and then ends up on the top or the bottom of the planet. So, in conclusion, you can make magnets turn over by pushing the field. Whee. Like that. So to reverse engineer means this would move, you turn off the magnet, projectile's now going in an opposite direction. What would that look like on a drawing? Well, to give you an idea, let's just say that's your ship. Incoming projectile. You can make a shield as wide as your ship. This, the north would be here, south would be here. This field will come out of here, join into the inertial line, and then go out to the other side. So it's either going to go that way or that way, and it will follow this, trying to get into here and into here, but you don't. The electronic controls would go that way, turn off, projectile flies that way. Coming in, projectile into there, turn off, projectile goes that way. So this is how simple things are when you actually kind of play with magnets and actually find out what they do, which is on some points it deflects. I can knock this over, which means that side movement means I can't hit the inertial line because the field is going over that way, and then it's wrapped in that way and then goes that way, which is why there's actually a large field and a smaller field, which I showed on that drawing, because that's where they wrap up. There's also a little bit of a field that's coming out of here and out of here due to the incoming energy, because magnets only work because we have an EM field. This is absorbing energy from the atmosphere, from the EM field, electromagnetic radiation, turns it into electricity inside, and then it displays itself as magnetism when it comes out. That's why Stonehenge and massive lodestones don't have strong magnetic powers anymore, because, as I've said, the energy within our system is going down, and yeah, so stuff isn't as powerful. God is deemed the rock, and magnets are a mixture of rock materials. If you don't believe me, go look it up. But there's plenty of rocks that are magnets. God is described as the rock, Jesus is described as the lily, and in a video, one of my latest videos, I showed a magnet underwater, which again we've termed electricity. Living water is electricity, but a magnet underwater produces a lily on the inertial line, and several on here, as well as vortex spin and all sorts, but you'd have to look at the other videos for that. Okay, so that's how to build a magnetic defense shield. You can't repulse them, but you can steer them away from whatever you want. Thanks a lot. My name is Lee, I follow the Christ, and I'm showing you all the things he shows me. Thanks a lot.